Welcome to the video for the Day 7 Quadratic Application Word Problems. Today we're going to look at our procedure for word problems. So what we need to do is we need to highlight the function in the word problem, identify the variables in the problem or function, and highlight what they represent. Read the question carefully to determine what variable needs to be solved for. So what are we looking for? So let's look at this first example together. We have let h of t equal negative 16 t squared plus 64t plus 80. So that's that idea of that's a function. We're going to highlight the function. It represents the height of an object above the ground after t seconds. So it's the height t seconds after. And we want to determine the number of seconds it takes to achieve its maximum height. And we're looking for a justification. So for this one, we know that from this number of seconds, they're asking for the number of seconds. So that means that I don't know the t value. So this tells me I'm looking for t. It takes to achieve its maximum height. Well, when we think about maximum height, that means that we're looking to see when does it hit its highest. If you think of a quadratic, this is a frowny face parabola because of the negative a value. It's going to have that frowny face shape, so we're looking for the axis of symmetry. That's going to cut it right in half. That goes through your maximum or minimum, so in this case, the maximum. So I'm going to use the t equals to find the axis of symmetry, and we're still going to use that same formula, but I'm going to use t instead of x. So the axis of symmetry, using t in place of x, would be is t equals negative b over 2a. Then I need to identify the a and b from my equation. So a is negative 16, that's the one with the t squared. B is the 64, the coefficient with the t. Then I can plug them into my formula. So then I have this negative 64 over 2 times the negative 16. Remember, depending on which calculator you're using, you can put this right into your calculator, or you can clean up top, clean up bottom. If you're using the clean up top, clean up bottom, this would become the negative 64 over negative 32. And then when we divide, we get 2. So my t equals 2 seconds, and 2 seconds would be my answer. Okay, so when you read these questions, remember, you always need to look and see, well, what's happening, what are they asking me for, and then approach it from there. So I knew that because I needed the maximum height when it happened, all I needed was the t value. If they had asked me for the maximum, the point where the maximum height happened, or for the maximum height, I would need to sub this t value back in to find out the height. Or, if it was the point, we would need the time and the height. So just always read the question and make sure that you're answering what they asked you to find. The next question here says, state the time interval in seconds during which the height of the object decreases and explain your reasoning. Well, to figure out how long this decreases, it's going to decrease until it hits that 0 value. So we could do one of two things. We could look at the table of values by plugging this in y equals, since it just asked me to explain my reasoning, or we could use the quadratic formula to find when it hits the 0. You could use quadratic formula or factoring, because they didn't give me rounding, so it might factor, to then figure out the 0 value and say, okay, well, it's going to decrease from this maximum height, because it's increasing until it hits maximum height. If we think of, again, you might want to sketch off to the side what this looks like. We know that it's going to go up and come back down because it has a negative a value. Now, where that fits on the x and y axis, that one I haven't figured out. I just kind of sketched only what the parabola would look like. So if you look at this, we know, well, it's going to be increasing till it hits its maximum height, and then it's going to decrease until it hits the root, where it equals a 0 height. So that's why I said, well, we can find the root and then figure out, okay, well, it's going to start decreasing it from this maximum point, which, remember, when does it decrease is asking for an x value, until it hits the ground here. And I will leave that one for you to figure out with just, like I said, you can either use the calculator to find the root, or you can use quadratic formula or factoring to solve for the 0, and then tell me what that means for when it is decreasing. So again, the reminder here, each question is different. You just need to read carefully, highlight your function, identify what the variables represent in the problem, and then read carefully to determine what are we looking for? What exactly do I need to find to answer the question? All right, and we'll do more tomorrow. Have a good night.